We're going to take a look now at exponential functions in which the exponent is the variable, and we're going to graph it. So, as we do for any graph, we make a little t-chart and then put various values for x. And these are the typical ones, 0, 1, -1, etc. And then we evaluate our function. So if x is 0, 2 to the 0 power is 1. If x is 1, 2 to the first is 2. If x is a -1, now here we have a case of 2 to the -1 is actually 1 over 2 to the first. So it's the reciprocal of whatever 2 would be to the first. 2 to the -1 is the reciprocal, 1/2. 2 to the second is 4. And the reciprocal, 2 to the -2, is 1/4. And 2 to the third power is 8. And the reciprocal, 2 to the -3, is 1/8. So we carefully plot these points. If it's, let's do the positive ones here. If it's 0, it's 1 right there. 1 is 2. 2 is 4. And 3 is 8. So this is the upper part of the curve. And then down here we get a -1/2, 1/4. For -1 it's 1/2. -2 it's 1/4. -3 1/8. Now as this line continues in this direction, it will continue to -infinity over here. Now, basically what I want to also show on this is that if this original function is modified so that you put a +1, what happens to your graph? Well, if we think of y equals mx plus b, this value out here, the b, is the y-intercept. So this is going to shift the graph. If it's a +1, it's going to shift it up 1 unit. And it looks like this. Shifts it up 1 unit, and it looks like that. If it shifts it up 2 units, it looks like that. Now notice your line now, as it goes in this direction, over here, this is called the horizontal asymptote, the x-axis. When it's at 0, when it's at 1, it's this axis. When it's at 2, it's at 2. Now, if it shifts it down 1, then this is what happens. We're going back to, there's our standard graph there. And we shift it down 1, it just goes like so. And our new horizontal asymptote becomes a -1. So a couple of things going on here. Now, going on a little further, we see instead of having a number all by itself out here, which is going to raise your graph up or down, let's get it back to where it belongs, right there. That's this one. How about if the exponent itself has a +2? Or a -2, like we see here. And we have to keep in background that this is often used to describe the relationship of x here as a point in graphing. So we have x minus h. So this 2 is your original h here. So let's write it this way. X minus h in here, like so. Now, when we do that, if our h is 2 here, what was its sign in order for it to end up as a positive 2? Because here, if it were 2, it would end up as a negative 2. So our h had to have been a negative. So when we take the opposite of a negative, we get our positive. So study this for a moment. This is going to be useful on the other side as well. So there's kind of a shortcut. When it's in a parenthesis like this, you take the opposite sign for whatever is there, and then you move it accordingly. So if it's a plus 2, you're going to move it over 2 units this way. So there's 1, and now there's 2. So this graph now is that. What happened? Well, we had our standard graph, but we're now moving it over 2 units to the left because our h value is now a negative 2. All right, let's put it back in where it was, over 2, right back there. Now, for this one, when we have x minus 2, what will our h value be? And the answer is a positive 2. So when we see it like this, x minus 2, again, the shortcut is opposite sign, so a positive 2. But this is the rationale behind it. So now this will move over 1 unit, 2 units, and this is what the graph looks like. Okay, so hopefully this was helpful to you, or for you, and we'll post it. As we continue with our study of graphing exponential functions, this is the one we've worked with so far, y equals x to the second, and this is that typical curve. Now how about if you have y equals 3 to the x power? What would this be like? Well, interestingly, as we do this, and I'll use, let me use black for this one then. If x is 0, we get 3 to the 0 power, which is 1. So that goes right there. If x is 1, 3 to the first is right there. Three to the second is 9, so we go second, up here is 9. And then down here, 3 to the negative 1 is 1/3. And then 1/9, and then it gets closer and closer to 0. So this curve, again, in here it's kind of hard to see, but it's like so. And it goes up to there, and it comes down like so. So this would be y equals 3 to the x power. Now, I don't know if you are seeing it, but what's happening here, this line is stretching up closer to your y-axis. Now how about this one? If x is 0, 4 to the 0 power is 1. So they all go through 1 actually, because anything to the 0 power is 1. Now if x is 1, it's to the 4th, so which is right there. And then 4 squared is 16, which is way up there. So this line, let me move this a little bit so I can draw it a little bit better here. Looks like so. So this is y equals 4 to the x. So again, the curve stretches closer to the y-axis as the number that we are expanding gets higher. So to the 5 to the x would be a little closer. 6 to the x, 7 to the x keeps getting closer, stretching closer to your y-axis. Now as you go down from 4 to 3 to 2, it is shrinking closer to your x-axis. And if we had a number like y equals 1.5 to the x and y equals 1.2 to the x, these lines would shrink more toward your x-axis. But how about if it were a fraction? What would this become? Well, let's plot that in green also, because if x is 0, 1/4 of the 0 power is 1, so it goes right through there. But how about if it's to the first power? Well, if x is to the first power, this is 1/4. So first power, 1/4 is right about there. How about if it's to the second power? Well, that would be 16, 1/16. And again, it keeps getting closer. So on this side, it looks sort of like that. But what's it going to look like on the other side now? Well, if we have to the -1, let me write that out to you, 1/4 to the -1, and I don't know if you recall dealing with negative exponents, we just flip that and it gets its reciprocal, which is 4. So if this is a -1, this goes up to 4, which is right there next to this other one. And if it's 1/4 to the -2, we just flip it and it becomes 16. So if it's 2, it goes to the 16th power, which is up there somewhere. And our curve here would look like so. Let me get this so I can give a nice sort of straight line here. Now, I don't know if you see the green lines. Do you see any resemblance to them? Yes, that this and this are what we call reflections across the y-axis, which happens to be your axis of symmetry. Now, if you had 1/3, the 1/3 would come out here a little further, and the 1/2 would come out a little further still. I don't know what happened to my red one here. It's disappeared. But anyway, it would come out this way. Now, keep in mind we had shifting. If we have a +1, then these would all shift up 1. If we had a minus 1, they would all shift down. If in the exponent it was a minus 1, it would shift over this way to a plus 1. If it was a negative 1, it would shift over here. Well, if it were a negative 1, it would shift this way in the parentheses, as we've talked about. And if it were a positive 1, it would shift this way. Okay, so lots of things about plotting exponential functions.